Today, I want to take a look at a deceptively simple mathematical puzzle, the equation 2 to the power of x plus 1 plus 2x equals 40. At first glance, it looks like something you could easily untangle with high school algebra, but it actually introduces us to a fascinating class of problems known as transcendental equations. Because this equation mixes an exponential term with a linear algebraic term, standard algebraic isolation completely fails us. You cannot just move things around to get x by itself. So, how do we tackle it? We begin with a practical, intuitive first step, inspection. Given that the right side of the equation is a clean, round integer like 40, it is highly probable that our solution is a small whole number. If we test x equals 3, the expression yields 22, which is too small. But when we step it up and test x equals 4, the math clicks perfectly. 2 to the 5th power plus 8 gives us exactly 40. Now, in mathematics, finding an answer that works is only half the battle. We also have to prove that it is the only answer. To guarantee uniqueness, we turn to calculus and define the equation as a continuous function. By taking its first derivative, we get a tool that tells us the slope of the function at any given point. In this case, the derivative is always strictly greater than 0 for all real numbers. This reveals that our function is strictly increasing. It climbs upwards indefinitely and never bends back down. Because it is strictly monotonic, it can only cross our target value of 40 exactly once, proving beyond a doubt that 4 is the unique real root. Finally, for the purists who demand an exact analytical roadmap, equations of this type can actually be explicitly solved using the Lambert-W function, a sophisticated, non-elementary function used to invert exponential equations. When you run this problem through that advanced framework, the complex layers gracefully collapse down to confirm what our intuition